In this problem, we're interested in the point on the curve y equals e to the x that is closest to the point 2, 0. So let's just take a look at this. I have this already sitting here in Desmos so we can kind of see what it looks like. So we have all these points here on e to the x, and we're looking to see which one is closest to 2, 0 over here. And I can see it's kind of getting shorter, not sure, so maybe somewhere around there. All right, so let's go back to our sketch over here, and I've got our picture right over here. So the first thing we want to do in this problem is have that graph y equals e to the x sitting here, and we want to have the point 2, 0 right here, and then what we're interested in doing here is minimizing our distance. And because I know I'm going to head to the Pythagorean theorem, I'm going to go ahead and call that distance right here c. Looking for a pen. Here, let's try that. Okay, there we go, C. So first thing we want to always do is figure out what is it we're trying to do. So in this problem, we are trying to minimize the distance C. All right. Now I said we were going to use Pythagorean theorem because any diagonal line, we can find the distance if we drop down a vertical and draw in a horizontal, and then we can use Pythagorean theorem to find C. So we could call this side A and this side B, and we could say that C squared equals A squared plus B squared. All right, so far so good, except we have far too many variables. Now we were told that this point was on the line or curve e to the x, which means at this point the x coordinate is x and the y coordinate is e to the x. All right, so that means that this side A, because the entire distance to here is 2, and this little distance in here is how far we go over for x, that means that our A must be the big one, 2, minus the small one, x. So A equals 2 minus x. So I'm going to put that in here. 2 minus x squared. And b, well, that's just the distance y. So b equals y, and y equals e to the x. So I can do e to the x squared. And now this side has one variable. Now, you might think we want to solve this for c, but as it turns out, and I'll write this down, c is at a minimum where c squared is minimum. So if c is minimized, c squared is as well. C squared is also minimized in the same place, minimized for the same x. And remember, we're looking for our critical number, our x, which is a critical number. And that x value that gives me a critical number is the same whether I leave this as c or c squared. So because it's an easier derivative, we're just going to use c. All right, here we go. So we're going to take the derivative of c squared with respect to x, and it equals, a little chain rule here, 2 times 2 minus x times to the first times the derivative of the inside. And here, when I look at that, I should be thinking, oh, that's the same thing as e to the 2x. So its derivative is 2e to the 2x. All right, so now once we have the derivative, we know we set it equal to 0 to find our critical numbers because our minimum occurs at a critical number. Oops, here we go. So I'm going to simplify this a bit. So let's see, when I multiply it, 2 times negative 1 is negative 4. And 2 times negative x times negative 1, that's going to be plus 2x plus 2e to the 2x. Now I happen to know that when I look at an equation like this, I am not going to be able to solve for x using algebra because I have one x here and the other's in an exponent and it's not going to work out. So this is one where I need technology, and I have Desmos ready to go here. I put it in here so you can see right here it's slightly different. But there's the negative 4 plus 2x and plus 2e to the 2x. And we graphed it. Now the nice thing about Desmos is there it is. It knows we're interested in where it's 0 right there. So we look for that spot. And there's our answer for a critical number. X equals 0.273. So let's go back over here. X equals 0.273. Our last step is to see what the question asks for. So let's go up here and we see the question asks for a point. And a point has an x and a y coordinate. So to answer the question, x, well that is this x coordinate, and y is going to be e to that point. So we can just write 0.273 comma e to the 0.273, or you could put that in your calculator to get another decimal answer.